Hello, let's continue and overview of artificial intelligence and machine learning. In this section, I will be talking about the engineering application of artificial intelligence, and I try to explain why it is different from application of this technology in trying to solve non-engineering related problems. So what is the difference between engineering versus non-engineering problems? They're not the same thing. What are the differences of these two types of problems? When you solve a non-engineering problem, what is required is general intelligence, human level intelligence. I will give you examples of that. And when you are solving the non-engineering regular problems that we always deal with it all the time throughout our lives, almost every day, what is not required is domain expertise. However, when you solve an engineering related problem, therefore, you need some domain expertise. You need a subject matter expert to be able to solve an engineering related problem. Very simply, that is why people who want to become an engineer, they go to the university and they spend 4 years of understanding and getting exposed in order to become an engineer. There are certain types of domain expertise that people learn when they go and take engineering related courses and become an engineers at least for 4 years. That's only if they get a bachelor's degree. It takes 2 more years to get a master's degree and almost another 4 years, a total of 10 years to become a PhD, and subject matter expert, a domain expert in a particular area of engineering. So there is a difference between those who are engineers and those who are not. As I mentioned, because those who are engineers, they spend a lot of time and a lot of effort in order to learn how to solve engineering related problems. Now let's talk about how the ImageNet, or the common types of application of AI, works. For example, this is one of the examples. As you can see, there are pictures of cats and dogs. It took a lot of time and a lot of effort of a lot of scientists to be able to build a convolutional neural network that its main objective is to recognize images, and in this particular example, be able to separate and distinguish between a cat's picture and a dog's picture. Using this technology, the algorithm is capable of identifying which picture is a dog and which picture is a cat. That is not very simple. It took a long time. They had to develop a whole new type of neural networks to be able to do that. It included an incredible amount of complexity of digital signal processing that had to come and perform some analysis and some modifications and some extraction of edges from the pictures, and then take that to the neural network and be able to identify the picture. All that said, the question is, from an intelligence point of view, do you need a domain expertise to identify the difference between a cat and a dog? A 5-year-old can do that in domain expertise. Other applications of AI and machine learning, mostly today, has to do, again, with artificial general intelligence. A good example here is the face recognition. If you use your iPhone in order to recognize your face and use it as a password to turn it on, it's not a simple process. It's a very, very complex process. But face recognition does not require domain expertise. Same is true for object recognition. An object recognition is an algorithm can identify pedestrian versus cars, versus bikes versus motorcycle, little children versus adults. And again, that's a very complex process, but again, it does not require any domain expertise. Another one is voice recognition. You use Siri or you use any other technologies that uses AI and machine learning in order to recognize your voice, identify what you're saying, make a difference between if it's you or somebody else. But your 3-year-old child can do the same thing, can identify whether it's you or your mom, you or your dad that are speaking. And in order for a child be able to write down what you say, recognize the voice, recognize what you think, and put it down, you can do it without even going to high school. So again, no domain expertise, a subject matter expert is required to do that. How about autonomous vehicle? Pretty much the same thing. They communicate with each other, they identify the objects, they understand how fast to go, they drive. In order for you to be able to drive a car or to drive a truck, do you need a bachelor's degree in engineering? No. You don't even need to be able to read. You still can drive a car. So domain expertise is not required. Translation is another one. A lot of time people who can translate 2 languages without being expert in particular languages, a 3-4-year-old child who has parents from 2 different countries who speak 2 different languages, he or she, the little child, can speak both languages and translate one to another. Again, no domain expertise is required. And finally, another example is caption generation of images. They developed LSTM, long short-term memory neural networks, as a part of a recurrent neural network, to build an algorithm that takes an image and can generate a caption. For example, here it can say that a bird is flying over water. And again, for that, you don't need domain expertise. All that said, what we're trying to mention is today's most common application of AI and machine learning mimics general intelligence. That was the whole idea behind it. This is only a pathway, of course, to artificial general intelligence. It may take decades or, I don't know, maybe even centuries before we have a complete artificial general intelligence. That has to do with mind and consciousness. I don't want to go through that, but nevertheless, it's a pathway toward general intelligence. And general intelligence, as I mentioned, does not require domain expertise. This doesn't mean that general intelligence is easy to accomplish. Please do not get me wrong. However, there is a difference between general intelligence and domain expertise. That's what I'm trying to mention, and that is why the application of AI and machine learning to solve engineering-related problem versus non-engineering-related problem would be different. As a final example, I will show you this picture that includes a lot of yellow dots and a lot of black dots. So if you ask someone that, can you draw a line, or can you somehow separate these two types or different colors of dots? Can you do that? I think even if you take a 5-year-old and give him a pen, he or she can do that. Draw a line and separate these. And when he or she does that, then you can tell him, hey, this is a non-linear separation. To a 5-year-old, you say, this is not a straight line. This is a circle. Now, can you separate still these two series of dots or circles, but not as a non-linear separation, a linear separation? That is where the difference starts. How could you do linear separation from this? If you do not know mathematics, at least have a high school degree for that, it's going to be very, very hard for you to be able to solve this. If you do have some background in mathematics, then you can find out that every dot has a distance from x-axis and y-axis here called x1 and x2. And I can calculate an r-square and then plot the r-square. And look what happened. Now, it can be separated using a linear separation, a linear line. Or if it doesn't matter whether it's a line or a plane, you can generate a third axis. x1, x2, and x3 goes in this direction, and you can separate these two and then separate them as a plane, a linear plane. So hopefully that explains the differences between engineering problems and non-engineering problems, and how we will talk about it a lot more as we go throughout this course, not particularly this course, but other courses that you take in the context of this certificate or master's degree in petroleum data analytics. You will see that how important this is, that being a petroleum data analytics expert engineer, you need to be a domain expert and an expert practitioner in AI and machine learning, so you know how to solve engineering related problems using data and AI. Thank you very much. We'll continue the rest of this.